In this video, we will describe how to use BMSEED's electrophysiology module for stimulation experiments with triggered recording. First, connect the output of your signal generator to the analog input 1 port of the controller. This will provide the analog signal that will trigger stimulation. We recommend using a pulse signal with a 4-volt amplitude, a 0-volt offset, and a 10% duty cycle. Set the frequency to the desired stimulation rate. For example, at 1 Hz, a stimulation pulse will be delivered every 1 second. In this example, we will set the frequency to 0.2 Hz to deliver a stimulation pulse every 5 seconds. To display this signal in the software window, we can create a pinned waveform that remains fixed at the top of the display to view alongside the signals from each port. Click Add a pinned waveform and select the Analog in 1 waveform under the Controller I/O tab. If the pinned signal does not show up in the GUI, check the Show Disable Channels option. Select the pinned channel and check the Enable Channel option to view the pinned waveform. Now select the desired stimulating channel by left-clicking the waveform tag. Then click Set Stim under Selection Properties. Check the Enable Stimulation Trigger option to allow edits to the Stimulation Parameters window. Under Trigger Source, select the Analog in 1 option for the signal generator. Select Edge Triggered to execute a stimulation sequence once every time the trigger transitions from an inactive to an active state. Select Trigger on High to provide a stimulus pulse when the signal voltage transitions 1.65 volts from a lower voltage state. By default, the stimulation sequence is executed immediately following a trigger event. In other words, the post-trigger delay is 0 microseconds. Under Pulse Repetition, select Single Stim Pulse to trigger a single stimulation pulse. If selecting a stim pulse train, then the number of stim pulses can be set, as well as the pulse train period from the beginning of 1 pulse to the beginning of the subsequent pulse. Set the post-stim refractory period to ignore additional trigger events during this period. As long as the trigger source remains high, the single stimulation pulse will repeat at a rate set by the post-stimulation refractory period. Under Stimulation Waveform, select the stimulation shape. Then select the stimulation polarity, such as cathodic current first, which is the standard practice in most stimulation experiments. Set the first and second phase durations, as well as the first and second phase amplitudes. Note: to extend electrode life, the net charge injection should equal 0. Check Enable Amp Settle to reduce the time it takes for the voltage produced during a stimulation pulse to return to its baseline level after experiencing a large stimulation artifact. We recommend setting the pre-stim amp settle value, or the time when amp settle engages before a stimulation pulse, to 0 microseconds. Prior experiments suggest setting the post-stim amp settle value, or the time amp settle remains engaged after a stimulation pulse, to 1 millisecond. To further access amplifier settle settings, select the option under the Stimulation tab. Switch Lower Bandwidth is the default and recommended mode that changes the lower bandwidth of the amplifier to a new value during the amp settle period. The default and recommended number for this value is 1000 Hz. Finally, the charge recovery function can mitigate the effects of residual post-stimulation charges in more long-term chronic experiments. This will force an electrode to ground or other fixed voltage during the specified post-stim charge recovery interval. However, charge recovery events may also induce artifacts during recording, so we recommend starting without this function to gather baseline data. If enabled, charge recovery settings can be further accessed under the Stimulation tab. Setting the charge recovery mode to current limited charge recovery circuit will pull the electrode potential toward a fixed voltage. Once all parameters have been set in the Stimulation Parameters window, click OK. Now we need to add a second stimulating channel with opposite polarity to minimize damage to the electrodes, as well as the cells or tissues. Copy the stimulation parameters that we set for one channel by left-clicking the stimulation channel and selecting Copy Stimulation Parameters under the Stimulation tab. For the second stimulating channel, choose a nearby electrode with low to medium impedance. Left-click the desired channel and select Paste Stimulation Parameters under the Stimulation tab. While the second stimulating channel is selected, click Set Stim to set the opposite stimulation polarity to the first stimulating channel. Here we will select Anodic Current first under Stimulation Waveform Polarity so that the two stimulating electrodes remain out of phase. Select OK to save the stimulation parameters. Once the stimulation parameters have been set, they can be saved now and loaded at a later date. To save the stimulation settings of all channels, select Save Stimulation Settings under the Stimulation tab. During your next stimulation and recording session, select Load Stimulation Settings under the Stimulation tab to load these settings at a later date. The stimulation will now be triggered by the signal generator connected to the analog input 1 port. To confirm this, select a stimulating channel, indicated by the pulse wave icon, to view analog in 1 as the stim trigger source. To record and save data, we will set up automatic recording using the stimulation signal as a trigger. In this mode, recording data is only saved immediately before and after the user-specified trigger signal is detected. This feature is useful when only the signals that immediately follow the stimulation pulse are of interest. Additionally, setting up triggered recording will save disk space. To set the trigger for data recording, click the Select File Name button and set the file name. Then click the Triggered Recording button. Enter the input channel that will provide the trigger, Analog Input 1, and select whether the trigger occurs when transitioning to a logic high or a logic low. Note, this should match the trigger source setting previously set in the Stimulation Parameters window. Specify how many seconds are saved pre- and post-trigger detection. Select OK to start the recording for each stimulus. Adjust the analog input 1 waveform by changing the analog voltage scale. If necessary, adjust the voltage scale of the recording sites as well. The software and recordings will continue until the Stop button is selected. A single data file is recorded for each stimulus, determined by the frequency we set in the signal generator. To verify this, open the folder with our specified file name, now appended with a timestamp. At 0.2 Hz, a stimulus occurred every 5 seconds. For 20 seconds of triggered recording, there should be 4 data files saved, 1 for each stimulus. After confirming that your setup is functioning correctly and successfully capturing the corresponding data for each stimulus, you can confidently proceed with your experiment and analyses. If you have any questions about setting up electrical stimulation with triggered recording using BMSEED's Electrophysiology module, contact BMSEED directly or refer to our Electrophysiology user manual.